Hello everyone, we're going to look at geometric series, and just like with arithmetic series where we had a few formulae, we also have the same with geometric series. So let's have a look at what those look like. Firstly, we have a formula for the general term, and you probably want to copy this down, and this is an equals a to the power r n minus 1. Now we know a is the first term, r is the common ratio, and just like in an arithmetic series where we had d, in a geometric series where things are being multiplied we have a common ratio, and this is, you can take any term and you divide it by the term before it, so those should be a's. Okay, so any term divided by the term before it will give us a common ratio. Now the sum of n terms Sn is given by the first term 1 minus r to the power of n over 1 minus r, and this can be used for when r is less than 1. However, if r is greater than 1, the same formula can be rewritten as a r to the power n minus 1 over r minus 1. So it can be written like that as well. Now there's a third formula, and that's for the sum till infinity. So I can write s, write infinity, and I've got a over 1 minus r. And this is for r is greater than minus 1, less than 1. So those are our formulae for geometric series. Let's now apply them and see how they work. Okay, so here's an example. We've got a geometric sequence, and it tells us the first term is 4 and the common ratio is a half. So let's write that down. Let's put down a equals 4 and r equals, the common ratio is a half. Find the sixth term, so let's start by doing that. And so we've got a6 is the first term to the power of n minus 1, and so we've got 4 times a half to the power of 5, and that should give us 0.125. Now the second term, find the sum of the first 10 terms. Since we got I equals half, the formula we can use is the one where we subtract the r, so we'll have the 1 minus r to the power n over here. Now we've got 4 as our first term, 1 minus a half to the power of 6, and oops, my mistake, it actually says the first 10 terms, so I should put down a 10 over here, okay, because we want the sum of the first 10 terms divided by 1 minus a half, and if you work that out you should get 7.992. Now for the third question, we've got sum to infinity of the sequence. So here's our formula, s infinity equals a over 1 minus r. If we substitute the numbers in there, we get 4 over 1 minus a half, and that gives us 8. Okay, so over here let's look at example 2. A geometric series has a common ratio of 0.5, so let's write that down. And when you're doing these sorts of questions, it's good to write down what you've been given. The sum of the first 5 terms is 77.5. So we know that, and we need to find the first term. Right, so since the common ratio is less than half, the formula we're going to use is this one here. So we've got sum of the first 5 terms equals a 1 minus r to the power n over 1 minus r, and this is a 1 minus 0.5 to the power n over 1 minus 0.5, which is 0.5, and we know we've been told this equals 77.5. We can now rearrange this. Do we know how many terms? For the first 5 terms, so we know that n is equal to 5. We can now rearrange this and work out what a is. So could you work out what a is and enter your results on the form for this, the accompanying form for this video. Thank you. Okay, let's look at example 3. We have a geometric sequence where the third term is 12 and where the sixth term is minus 96. Right, so it's not the sum of the terms, it's just the general term. So the formula we've got to use is for general term, an equals a to the power r n minus 1. So now for the third term, we therefore have a3 equals a to the power r to a times r to the power of 2, because we know n equals 3 and this equals 12. We also have a 6 equals a r to the power 5, and this equals minus 96. And what we also do is work out the first term and the common ratio. Now if we just call this equation b and equation a, if we divide equation b by equation a, the a's will cancel, so b divided by a will give us minus 96 over 12, and that will give us ar to the power 5 over ar squared. We can cancel the r's off and we're left with r cubed, and 96 over 12 should give us minus 8. And since it's a cube, so we've got to be careful when we put that in the calculator. Since it's a cube, we know it's, r is a negative number, so r gives us minus 2. Now we also need to work out the first term. Now we can choose any one of these equations, and so we've got minus 2 all squared equals 12, and then you've got an a over here, so this is our equation a. And we can use this 12 divided by 4, which gives us 3, and so a equals to 3. Okay, so for part 2, find the sum of the first 8 terms. So S8 equals a rn minus 1 over r minus 1, and again we're using this term because the common ratio r is minus 2, so it's less than 1. And if we substitute our values in, we'll find the sum of the first 8 terms. We know what a is, we know what r is. Could you work this out and enter your results on the form, please? Thank you. Okay, so let's look at this example here. The sum of an infinite geometric series with common ratio minus 0.25. I like writing this out, so let's just write that over here. So minus 0.25 is 6.4. Find the first term, right? So let's write down what they've given us. The sum of infinity equal to infinity is 6.4, and equals a over 1 minus r. We know r equals minus 0.25, so we've got 2 pluses there, and we've got that. If we rearrange that, we should just be able to get a equals to 8. The second question, the second part, so let's label those. The sum of an infinite geometric series with the first term 3 is 5, so let's write that down. A equals 3, and the infinite series there equals 3 over 1 minus r, and this equals 5, and we're asked to find out what R is. Again, if you rearrange this, pause the video, have a go, then we should be able to get R equals to 0.4. Okay, let's look at this example. Example 5, the sum of the geometric series with first term A and common ratio -2 is 513. Find the number of terms. So again, we've got an SN scenario, and let's just write down A equals 3 and R equals -2, and sum to N, which we don't know, is that. Now since R equals -2, the form we'll use is this one here, 1 minus R to N over 1 minus R. And if we were to substitute the values, we'll have 3, 1 minus, and we've got -2 to the power of N over 1 minus -2, which is 1 plus 2, and we've got 513. And if we were to rearrange this, we'll have 513 equals 1 minus -2 to power N. And if we rearrange this, we've got -2 to power N equals minus 512. And probably at this stage, through trial and improvement, you can take some guess at the values of this power, and you should get N equals to something. Do you want to work out what? It's a positive number, and it's a whole number. Do you want to have a guess at what that is and enter your result on the form? Thank you. Okay, let's look at this example, which is quite nice. It's a worded question, and we need to make sense of it. So let's look at what we've got. Carlos saves money every year. The first year he saves £100. Each year he increases the amount saved by 10%. Okay, so therefore it's not a fixed amount that's being added, it's something that's being multiplied. And after how many years do Carlos' savings first exceed £1,000, excluding any interest he has earned? So let's have a look at what we can do. The first thing is we recognize it's a geometric relationship, and A equals 100 for the first year, and R equals 1.1. Okay, you can work that out, because if we know for the second term, so let's write down A2. The second term he's just saved 10%, so that must be £110. Now for the first term we know it's 100, and so if you do 110 over 100, we get 1.1. So that's our common ratio. So we want to work out this sum after n years. So let's write that down. Sum after n years equals 100, 1.1 to power n minus 1 divided by 1. So let me just get a rubber. There you go. 1.1 take away 1. So if we simplify this down, we have 100, 1.1 to the power n minus 1 divided by 0.1, and that will give us 1000, 1.1 to the power n minus 1. And when this exceeds 1000, so we want to find out when this is greater than 1000. Now if we divide through, we get 1.1 to the power n minus 1 is greater than 1, and 1.1 to the power n is greater than, we can take the 1 to the other side, so we get a 2. Now at this point we can either use logs, so we can take the logs of both sides. Let me just put an arrow into it over here. So if you know how to use logs, you'll take the log of 1.1 to the power n is greater than the log of 2, and we end up with n, the power comes down, n is greater than 7.27. If you haven't done logs, then I guess use trial and error. and we know that we can see 1.1 to the power 7 equals 1.95, so it can't be 7, and 1.1 to the power 8 equals 2.14, and I guess they're assuming the years is a whole number, it's not a fraction, it's not going to be 1.5 years, so we'll take 8 and we'll say therefore after 8 years the value exceeds 1000.